Welcome. In today's problem, we'll be looking at the chess king problem. I've always been very fascinated by the intersection of chess and math, and this is one such problem. So let's get started. All right, so a chess king is set to attack all the squares one step away from it, horizontally, vertically, and diagonally. For somebody who knows how a chess king moves, this pretty much covers that. For instance, a king in the center of a square of a 3x3 grid attacks all the 8 squares around it, as shown below. So basically, that's the grid. And if imagine a king in the center, and all the squares around it is going to be controlled by the king, and therefore no other king can be there. That's what we call as no king's land in chess. Suppose a white king and a black king are placed on different squares within a 3x3 grid so that they do not attack each other. In how many ways can this be done? Okay, so what they're basically saying is, look, if there's a king in the center, then you can't place a black king anywhere on the 8 squares around it. The red circles basically saying those are the no king's land that a black king cannot land in. However, it is possible to have both a white king and a black king inside a 3x3 grid. The question is, in how many different ways? If you'd like to solve this problem, you can pause the video here, try to solve it, come up with an answer, and then continue watching it and verify if you got the right answer. So this is one example of a configuration. So if the white king were on the top left corner, then you could place a black king in any of these 5 squares, excepting the 3 dots, the red dots that I've marked, which is the no king's land. You cannot have a black king there, but any of the other 5 kings that I've marked could be a possible configuration. Similarly, if the king were in the center, in the top center, then the 5 squares around the king would be the no king's land, and still giving an opportunity for the black king to be placed in any of the 3 bottom squares. Okay, to solve this problem, you got to apply the principle of fluid intelligence. Know the differences between similarities and similarities between differences. What do I mean by that? Well, there are 9 squares here. Know the differences, which means there are 4 squares which are very, very similar. These are the corners. And similarly, you would have 4 squares which would be on the edges, which are very, very similar. And of course, the center is different, and we've already dealt with the center. Center cannot have a black king. It's the configuration is not possible. But let's focus on the corner case. So if a white king were to be placed on any one of the 4 corners, we know that there are 5 possible configurations with the black king. Since there are 4 corners, the number of possible ways or number of configurations of black and white king both being there on a 3x3 grid is going to be 4 times 5 or 20. And similarly, for the edges, you have 4 edges, and each edge has 3 configurations possible. So it's 4 times 3. And therefore, the answer is 32. If you got this, fantastic. Please leave your comment about how you solved it and how you like this particular solution. We're not going to stop here. We're going to go a step further. So we have this problem, and we understood this very well, but there's nothing which says that it has to be only a king. But what if instead of a king, you had a rook, or a bishop, or a knight, or a queen? How would your answer change? These are the kind of questions that you want to explore, ruminate, think about, and try and solve. Let's go one step further. The same question, but instead of a 3x3 grid, what if we were to have a 4x4 grid? How would your answer change if there were to be 2 kings placed on a 4x4 grid, or for that matter, a 5x5 grid? And this is the non-routine exploratory math that we love to do. And if you love it too, please don't forget to subscribe to this channel. Click on the bell icon so that you're made aware of any new post that comes in. And don't forget to like and share this video. Thank you so much for your time. Looking forward to the next project.